7.3, Sum and Difference Identities. You're getting some new formulas here, and it looks like there's 6, but there's really only 3 because there's 2 cosines, 2 sines, and 2 tangents. The only difference is where the positives and negatives are. So be careful on that. Don't need to memorize them. You're just going to need to use them. So what those new equations are good for is they're good for finding values that we couldn't before. We should be fairly comfortable with the chart, and we know the chart, but we only dealt with 30 degrees, 40 degrees, 60 degrees, 90 degrees, and multiples thereof. Now I'm going to be able to do some more. Okay, we're going to find the exact value. Exact value implies that you're not supposed to use your calculator. When it says exact, just figure on using the chart. Okay, so what this is going to entail is turning your 15 degrees into numbers out of the chart. And I see a couple of different ways to do this, but the first way that comes to mind is instead of saying 15, I could say 45 minus 30 degrees. Same thing. That's still cosine 15 degrees, but what I've done is I've changed it into one of my formulas. Okay, so if you look back at the formula that says cosine minus, that's what I'm looking at. I'm looking at the cosine minus formula. So the cosine minus, kind of how I look at it, if it's cosine minus, I kind of remember when I'm looking at it, it's like cosine plus sine. And so in my head, I might say something like cosine plus sine is what I'm going to have to do essentially. And how this is going to work is I'm going to say cosine of the first one, cosine of the second one, plus sine of the first one, sine of the second one. That's the pattern. Cosine plus sine. And what we've got at this point are 4 chart questions. We look at the chart, and we know cosine 45 is square root of 2 over 2. And cosine 30, square root of 3 over 2. Sine 45 is square root of 2 over 2, and sine 30 is 1/2. We've got those 4 bits that we should be good at by now. Okay, the rest of this is just putting it all together. One of the hard things about this lesson is just working with fractions. You've got to be able to deal with your fractions. All right, now I'm going to write something down and then I'm going to erase it because I want you to skip this step, but I need you to make sure you see where it comes from. When I multiply these 2 fractions, you multiply numerators, you multiply denominators. You're going to get square root of 6 over 4. All right, same thing over here. You're going to multiply and get square root of 2 over 4. We're going to add those 2 things together. I want you to skip that step and combine the fractions. So I'm just going to go straight to here. I know square root of 2 times the square root of 3 is square root of 6. I'm going to have plus the square root of 2, and all that's going to be over 4. And that's your answer. That's your exact answer. You can check your work, put her in degrees, and we know cosine 15 on the calculator is approximately this. So you should be able to say square root of 6 plus square root of 2 all over 4 and get the same thing, 0.9659 or whatever. That's the same thing. That's exact though, with the square roots, exact. It's a little bit harder when we're talking about radians, 5 pi over 12. We're just not as good with radians as we are with degrees. We're going to do the same thing, but it's not nearly as obvious, okay? So if you look at your chart has these angles in it. 0, pi over 6, pi over 4, pi over 3, pi over 2. And what happens in this class a lot when we're dealing with fractions, if we want to make sense of it, change them all to be the common denominator. That's how you compare fractions, right? I know you don't remember, but back when you were a kid, when you first started learning about fractions, it was easy because your teacher only gave you common denominators. That was easy. So change these all to a denominator of 12 and it'll be a lot easier for you to look at. So I'd multiply this by 2 over 2. That's 2 pi over 12. And 3 over 3 makes this one 3 pi over 12. And 4 over 4 makes this one 4 pi over 12. And 6 over 6 makes this one 6 pi over 12. Once you're looking at a common denominator, it's pretty easy to see how to make 5 pi over 12. I'm just going to add these two. 2 pi over 12 plus 3 pi over 12 is 5 pi over 12. That's the only way I can see to make it happen. 2 plus 3 is 5. So let's come way over here, and I'm going to say this is cosine 2 pi over 12 plus 3 pi over 12. You want to kind of write small in this lesson. I didn't give you a whole lot of room, all right? And you know, maybe it would be better for you if you actually wrote down the reduced version. That's pi over 6 plus pi over 4. That's really what we want to get to because those are the numbers in the chart, right? But what you have to notice is that this is a cosine plus pattern. This is a cosine sum. So look at your formulas. Find the pattern for cosine plus. Cosine plus. That's going to be cosine, cosine minus sine, sine, right? Cosine, cosine minus sine, sine. That's kind of the pattern that it says. Cosine, cosine minus sine, sine. So all we're going to do is we're going to say cosine of the first one times cosine of the second one minus sine of the first one, sine of the second one. I know this looks rough, but the good news is they're all kind of the same. You're going to do a whole bunch of different things that are really kind of the same thing. We've got 4 chart questions. You should be able to tell me cosine pi over 6. Cosine pi over 6 is what? Square root of 3 over 2? Cosine pi over 4 is square root of 2 over 2. Sine pi over 6 is 1/2. Sine pi over 4 is square root of 2 over 2. So put that all together. You're going to see a square root of 6, right? Over 4. And you're going to see a 1 times square root of 2 is square root of 2 over 4. I would skip a step and say this is going to be square root of 6 minus square root of 2 all over 4. Exactly. Don't pull out your calculator. I don't want to know the calculator number. That's your answer. Now, part C is actually the easiest one on the page, even though it might look like the hardest one. But the important thing to recognize is the pattern. I see the pattern cosine, cosine minus sine, sine. So look at your formulas and find that pattern. Cosine, cosine minus sine, sine. Cosine, cosine minus sine, sine. That's the first one, right? That's the one at the top. That's a cosine plus. We're taking the right side of the equation and moving it backwards to the left side. This is going to be cosine plus degrees, degrees. Don't forget the degrees. So I'm going to add those two numbers. 87 plus 93 is 180. I've got cosine 180. And we ought to be able to do this. Now, this is a quadrantal angle, and if I'm doing a quadrantal angle, I'm not using the chart. I'm using the circle. Okay? So you need to be comfortable with using the chart and the circle. We're always talking about the unit circle. And 180 degrees is right here, so I'm concerned with the coordinates of this point on the circle at 180 degrees. Well, we know the coordinates of that in the unit circle is negative 1, 0. So it should be easy. Cosine is the x. Cosine 180 is negative 1. That answer is negative 1. Number 2. Okay. Find an angle that satisfies each of the following. All right, here's the deal. We've talked about cofunctions before. Sine and cosine. tangent and cotangent, secant and cosecant. Those are cofunctions. And we had this property that one of the angles plus the other angle was 90. And so this question is not that bad. Once you recognize that these two are cofunctions, you can just say theta plus 25 equals 90. So subtract that over, theta equals 65 degrees. Cofunctions. The angles, the arguments add up to 90. So part B, same thing. These are cofunctions, so I can just say theta plus negative 30 equals 90. Add that over, you're going to get theta equals 120 degrees. Third one's harder because you're in radians. And so you wouldn't say they add up to 90, you'd say they add up to pi over 2, because that's the same thing, right? That's the same angle. So I'm looking at 3 pi over 4 plus theta equals pi over 2. Okay? Because we're in radians, we can't say 90 degrees. That'd be like comparing Spanish to English and talking half your sentence in Spanish and half your sentence in English. It would be super confusing. So if we're going to go in this language of radians, we're going to go in this language of radians. Pi over 2 is the equivalent to 90 degrees. Now, we're adding fractions. We've talked about this enough times to recognize that when you add fractions, you need a common denominator. This is going to be a lot easier for me to talk about if I make this 2 pi over 4. Okay? Pi over 2, that's 2 pi over 4. Was that confusing? Multiply by 2 over 2 to get a common denominator. That's 2 pi over 4. Okay? So what we're going to do is subtract this over. So your theta is going to equal 2 pi over 4 minus 3 pi over 4. Or negative pi over 4. Why is that one harder? It's harder because you're not as good at fractions as you are with non-fractions. So the fractions is what makes that kind of difficult. But just keep in mind, when you want to compare two fractions, get a common denominator. Makes it a lot easier. Now, for some reason, I accidentally put this one twice, so let's skip that and go to number 3. It says if one of the angles is a quadrantal angle, then the identity allows us to write the expression in terms of a single function. Okay, quadrantals are nice. 90 degrees, 180, 270, 360. Multiples of 90 are easy because they're always going to go back to ones and zeros. Stuff's going to fall out. Stuff's going to cancel out. And that's what's going to happen in number 3. Okay, write cosine 180 degrees minus theta as a trig function of theta alone. Those directions might be kind of confusing, but what's not confusing is this is a cosine minus. So find that pattern. Cosine minus, cosine minus, cosine minus, cosine minus. The pattern says that's going to be cosine, cosine plus sine, sine. All I'm doing is just looking at the formula. Cosine minus, that's going to be cosine, cosine plus sine, sine. So cosine of the first, cosine theta, plus sine of the first one, sine theta. Same thing as what we've done before, but before we had 4 chart questions here. This time I can only do 2 of them. I can only do the ones with the numbers in it. I'll have to leave the thetas there. Leave the thetas alone. Well, we got 180, and again, 180 is a quadrantal. Quadrantals are easiest to look at the circle. 180 degrees is talking about this point. We know that cosine 180 is talking about the x, that's -1. And we know sine 180 is talking about the y, that's 0. So if you fill in your x there and your y there, a lot of stuff's going to happen. A lot of stuff's going to drop out. 0 sine theta is 0. So we can cancel that thing. We can cancel that. -1 cosine theta, that's just going to be negative cosine theta. Turned out kind of nice. I'm sorry? Well, where did you get stuck? Did you get stuck with the purple? Okay, the red part. So in order to do the red part, you have to look at 180 degrees. So 180 degrees is going to put me at this xy point, right? And I know that cosine 180 is talking about the x coordinate, so that's -1. And I know sine 180 is talking about the y coordinate, so that's 0. So all I did was I filled in cosine 180 was -1 and sine 180 was 0. All right, then everything's going to start canceling out, falling out. I said, I'm sorry? 0 times anything is 0, right? Okay, take a deep breath, okay? This is maybe the most important problem of the section, and it's the hardest one to understand of the section. Once you get it, but it takes a second to get there, and I see a lot of silly mistakes on this one. This is definitely a test question, though, all right? So we suppose that sine s equals 3/5 and cosine t equals -12/13, and both s and t are in quadrant 2. Find cosine s plus t. A lot going on there. The first bit of action that you should take is you need to notice this is what we're trying to find. So that is one of our new equations, right? It's a cosine plus. And so the first thing I'm doing, maybe I don't know what to do with anything else, but it's pretty easy for me to say, oh, that's just the cosine plus. So I'm going to follow that pattern. It says cosine of the first one, cosine of the second one, minus sine of the first one, sine of the second one. Your variables are a little bit confusing and weird that they're s and t. It could be anything. It could be x and y, theta and beta, whatever. In this case, it's s and t. Do not leave those out. Do not skip over it because you need to know which one's which. So it's cosine, cosine minus sine, sine. All right. So we are going to want to plug in these 4 values. And the easy part of this problem is they gave me some of them. They gave me sine s. Sine s is 3/5, so I can plug that in right here to its spot. They gave me cosine t equals -12/13, so I can plug it into its spot. So far, so good, but here's where the wheels kind of fall off for some students, and I've seen it happen a million times. I don't have the other 2 pieces. I'm going to have to work for it. I'm going to have to figure out how to fill in those other things, and people want it to be easier than that. And people are going to do something silly, like they're going to say, okay, so s equals 3/5. I'm going to plug in right here, I'm going to say cosine 3/5, and that doesn't make any sense at all. Don't do that. It doesn't make any sense because s does not equal 3/5. S does not equal 3/5. Sine s equals 3/5. I can't do that. All right, I'm not going to be able to do that. What I'm going to have to do is what we did in chapter 5. They're describing a picture. So I think the easiest way to do this is to draw a picture. So S is in quadrant 2. I'm going to draw a picture of S in quadrant 2. So quadrant 2, and there's an angle S in quadrant 2. Okay. What we knew about in this chapter 5 was this angle defines some xy point, right? But this xy point defines a circle and a triangle. So for S, I'm going to draw this right triangle. And what they gave me up here, sine S equals 3/5. Well, remember, we know the sine ratio is y over r. So they're essentially giving me 2 sides of this triangle. Okay. I need to find that third side of the triangle, and you can do that by Pythagorean theorem. Now, at some point, you're going to know how to do this one in your head. because these numbers come up a lot. Yes? What? Well, I'm not ready for cosine yet. I need, when cosine is x over r. So in order to find cosine of s, I need that x side. And I'll put x over r. That's what I'm trying to get to right here. Okay? So think about it. Pythagorean theorem would say x squared plus 3 squared equals r squared. Subtract the 9 over x squared equals 16. Square root, you're going to get plus or minus 4. But the thing about it is we're in quadrant 2. And in quadrant 2, oops, we know that x number is going to be negative. Okay? X is negative 4. So guess what? If I have to do cosine of s, cosine of s is going to be x over r negative 4/5. Negative 4/5 goes right there. X side is negative 4. R side is 5. We've done this before. Now we're going to do it again because we have to find something about t. The last blank is sine t. We don't have a picture of t. You're going to need to draw another picture to do t. So t is also in the second quadrant. So let's draw an angle t in the second quadrant. Now again, that point defines a circle and it defines a triangle. They gave me cosine, and so I know cosine is x over r. They're giving me the x side and the r side in that triangle. X over r, the cosine ratio. We've done this. Okay? In order to finish up, I need sine, so I'm going to need y over r, right? I'm going to need y over r, so I need that side. You can use Pythagorean theorem again. Uh-oh, where are we at? Y squared plus x squared. Well, let's go and do that in my head. 12 squared is 144. Equals r squared, 13 squared is 169. You subtract that over, y squared equals 25. Square root plus or minus, going to be plus or minus 5. But we know it's going to be positive 5 because we're in the second quadrant. Y numbers are positive there. Once you've done these a few times, you don't need to go through all of the steps. You'll even skip the Pythagorean theorem because 5, 12, 13 is a really common right triangle. 3, 4, 5 is as well. But once I know that y side, I do y over r, because that's sine 5 over 13. Sine t is 5/13. Okay? The rest of this is just cleaning up your fractions. I'm multiplying fractions, so multiply the top, that's 48 over 65. Multiply these fractions, 15 over 65. Put it together, 48 minus 15, that's 33 over 65. That's an important question. Okay, it took me a long time to walk through and talk through that. Once you know what you're doing, this doesn't really take that long. You do the same thing kind of over and over and over. Find your formula, plug in the ones you know, draw a picture to figure out the ones you don't know, simplify a fraction. Questions on that? Yeah, there is a way to do that without the pictures, okay? If you were going to do that without the picture, and maybe you'd rather do this, I wouldn't, but maybe you would, okay? Check it out. We know, let's see, where are we at? They gave me sine S was 3/5, and I wanted cosine, what did I want? Yeah, cosine S. Okay, so what you could do is use one of those identities. We know that sine squared plus cosine squared equals 1, right? So maybe you'd rather do this. Sine squared is going to be 9/25. So if I can solve this, I need to isolate the variable. So we isolate the variable, subtract 9/25 over, and it's hard to do until you change this to 25/25. Common denominator. Do this so often. C squared is going to equal 16 over 25. Square root both sides. That's going to give you plus or minus 4/5. We are in quadrant 2, so we would choose the positive version of that. So yes, you can do this without the picture by using those identities. I just find most people would rather draw the picture than use the identity, but maybe you'd rather use the identities. Okay, you can do that totally. All right, number 4a. Find the exact value of sine 75. Well, we've already kind of done one like this. 75. Exact value means use the chart, but I don't have the chart, or I don't have 75 in my chart. So your job is to make 75 out of stuff that we know in the chart. Well, how about 30 plus 45? That'll work. We're going to say sine 75 is the same thing as sine 30 plus 45. And we've already done one just like this. You just got to pick the right pattern. That's a sine plus. So sine plus, the pattern says sine cosine plus cosine sine. That's what the pattern says. Sine cosine plus cosine sine. I don't have it memorized. I don't expect you to have it memorized. I expect you to be able to look and find the right one. Okay? Sine cosine plus cosine sine. So sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. We've got 4 chart questions. Now, incidentally, if you switched around and said 45 plus 30, that'd still be right. It's just switched around. It'll still be right. As long as you get 75, it'll still work. Okay? Why wouldn't I want to do 90 minus 15? Because that's 75. I don't know 15. Right. 15 is not in the chart. I don't know 15. Question? How do I figure out what equation it is? All I'm looking at is this. Okay? I see a sine sum. So I just look at my formulas and find the same one. There's one that says sine plus. There's one that says sine minus. There's one that says cosine plus, cosine minus, tangent plus, tangent minus. I'm looking at the one that says sine plus. But at this point, I just fill in from the chart. Sine 30 is 1/2. Cosine 45 is square root of 2 over 2. Cosine 30 is square root of 3 over 2. Sine 45 is square root of 2 over 2. You start seeing the same numbers over and over again because, of course, we're using the chart over and over again. I'm going to skip a step here, but that's going to be square root of 2 over 4, and this one's going to be square root of 6 over 4, so I'm just going to combine them into one fraction. Square root of 2 plus square root of 6 all over 4. Yeah. Okay. Well, okay. Good question. Great question. Okay. Here's what I usually do. Something like this, it's hard to tell because we don't really know what those numbers are and we can't visualize them. So what if I said something that we do know? If I said the square root of 9 plus the square root of 16, no, that's a terrible example. Square root of 9 plus the square root of 4. Okay? You're wanting that to be the square root of 13 because 9 plus 4 is 13, correct? But if you think about it, the square root of 9 is 3 and the square root of 4 is 2. So that can't be right. Okay? It has to do with order of operations. So yes, that's a great thought. Why don't we add the 2 and the 6 and make 8? It doesn't work out that way because of the order of operations. All right? Square root of 9 plus square root of 4 is a lot more obvious why that's not going to work. Okay? But you could check it out on a calculator, I guess, and see why it doesn't work. Do square root of 2 plus square root of 6 on a calculator. I bet that's not going to equal the same thing as square root of 8. It's not equal. All right. Okay, 4b. This is a tangent problem, so rule it out. You're going to use a tangent formula. The problem with this one is it's in radians, and we're not very good at our fractions. So you got to go back and say, all right, okay, the angles in my chart look like this. If you want to, I mean, you can, but I mean, if that helps you understand it better, but if you already know what I'm going to say, then I wouldn't. But the reason this one's hard is because we don't know how to produce that 7 pi over 12. That's why I think it's important to get a common denominator. Okay, get a common denominator. 2 over 2 makes 2 pi over 12. And 3 over 3, that's going to be 3 pi over 12. And 4 over 4, that's going to make 4 pi over 12. That's going to do it right there, right? If you add those two together, that's going to make 7 pi over 12, right? That's what I'm trying to do. So my point here is get a common denominator so the fractions are easy to compare. If I add those two, that makes 7 pi over 12. All right, so that's what I'm going to do. I'm going to take this 7 pi over 12, and I'm just going to rewrite as 3 pi over 12 plus 4 pi over 12. Now, it might be easier for you to write the reduced. That's actually what? That came from pi over 4, and that came from pi over 3. Okay. That's going to be a lot easier for us to deal with now. We take the 7, we get rid of the 7, we write it as a sum because we've got a formula for the sum. Our whole point is to take something that was not in the chart and boil it down into some things that are in the chart so I can use my formula in a chart and figure out the exact. Okay? So you got to find your pattern. This is a tangent plus, and that should be obvious. It's a tangent plus. So find the formula that's a tangent plus. Tangent plus pattern says tangent of the first one plus the tangent of the second one all over 1 minus tangent of the first one times tangent of the second one. I know that looks super confusing, but all I'm doing is it's all pattern recognition. I'm looking for the appropriate pattern. Tangent plus, that's what it is. Right. Now, can't remember if I have a chart in here or not. Yeah, here we go. Okay. If I'm doing tangent pi over 4, remember tangent pi over 4, you're dividing those two things, right? The one in the room doesn't have that, so obviously it's going to be 1, but it's 1 because you're dividing this by this. All right? Tangent pi over 4 is 1. Tangent pi over 3, you're dividing these two, right? You're dividing these two, and those 2's cancel out, and that's why it's going to be square root of 3. This is going to be square root of 3. So this problem cleans up quite nice. We're looking at 1 plus the square root of 3 on the top. And on the bottom, we have 1 minus, and consider 1 times square root of 3 is just going to be square root of 3 right there. 1 plus square root of 3 over 1 minus square root of 3. That's almost finished, but we should know when you've got a square root on the bottom, we're going to have to rationalize. Good. We're going to have to do that conjugate rule. And so the conjugate rule says we're going to multiply by a very special form of 1. In this case, we'll put a 1 plus, we'll put a 1 plus square root of 3 over 1 plus square root of 3. And we FOIL. And we FOIL the top, or we distribute the top. We're going to get 1 plus square root of 3 plus square root of 3 plus 3. Square root of 3 times square root of 3 is square root of 9. That's 3. On the bottom, I'm going to do the same thing. 1 plus square root of 3 minus square root of 3 minus 3. what happens is those two square roots cancel out. Cleaning up like terms, I have 4 plus 2 square root of 3 over negative 2. And now I can reduce this and skip this step if you need to or if you want to, but you can think about splitting the fractions. I usually skip that step. That reduces to negative 2. That reduces to negative square root of 3. There's your answer. Okay, now again, if you wanted to check your answer, you could put it in radian mode. We were doing tangent 7 pi over 12. Hopefully that's the same thing as negative 2 minus square root of 3. Same thing, okay? All right. Where are we at here? How are we doing on time? I think we can do, let's do a couple more real quick. 4C. This one's actually not that bad, okay? Notice the pattern though. Sine, cosine, minus cosine, sine. Look for that pattern in your formulas. Sine, cosine, minus cosine, sine. That's going to be this one. Sine, cosine, minus cosine, sine. So it's going to be a sine minus. It's going to be a sine minus. So all we have to do, or what we're going to do, is we're going to subtract those two angles. That's a sine minus. That's the pattern. Well, 40 minus 160 is negative 120, which is good review from chapter 5. We should be able to do this. This is a chart question, and you should be able to do this. Sine of negative 120. So what we would have done back in chapter 5 is said negative 120 takes us around backwards to here. This is a 60-degree reference angle because it's 60 off of the x-axis. So essentially, I'm doing a sine 60 in the third quadrant. Well, sine 60 is square root of 3 over 2. But being in the third quadrant means that my sine or my y value is negative. That's negative square root of 3 over 2. Now, incidentally, if you notice this negative angle, you could have used one of your negative angle identities and called that negative sine 120. Sine 120 puts us in the second quadrant. It's still a 60. So it's like we're doing sine 60 in the second quadrant, but then you just carry this negative down to the front because there's a negative right there. Same thing. I don't know that that's easier than what we did. Okay, number 5. Write each function as an expression involving functions of theta. All right, what you've got to get into the habit of is noticing the pattern. Notice the pattern. That's a cosine plus. That's a cosine plus. Okay, so your pattern says cosine, cosine, minus sine, sine. That's what the pattern says. Cosine plus. That's what the pattern says. So I'm doing cosine, cosine, minus sine, sine. Cosine, cosine, minus sine, sine. I don't have them memorized, so I find myself, I keep having to look back. All right. We can do cosine 30. It's in the chart. Cosine 30. Square root of 3 over 2. We don't know cosine theta, though. We don't know anything about it. Sine 30 is 1/2. Don't know sine theta. That's all I can do. That's all I can do in that problem. Tangent, 45 minus theta. Again, I don't need you to be able to just immediately whip this out, but I need you to be able to tell which pattern it is. It's a tangent minus. And so the tangent minus pattern is going to be tangent minus tangent over 1 plus tangent times tangent. Look like that. Yeah, we're done with A. That was it. Okay, so tangent 45. What tangent 45 is? Right. Tangent 45 is 1. Tangent 45 is 1. And how you're going to do that on your chart is you're going to say, all right, we know tangent 45, y over x, sine over cosine, that's 1. Okay, that's 1. So that's 1. And that's really all I'm going to be able to do. I can't do anything with the theta. I don't know anything about theta. So let's just clean this up. The top's going to say 1 minus tangent theta. And 1 times tangent theta, that's just going to be 1 plus tangent theta. Should what be 2? Are you saying 1 plus 1t is going to equal 2t? One of them has a variable on it, one of them does not. They don't combine. You'd have to do this multiplication, whatever that gives me, before you do the addition. We can't say 1 plus 1 is 2 there. Okay, good thought, good idea. But if it's not like it's 1 plus 1 right there, it's 1 plus 1 tangent. Okay, 1 tangent theta, right? So this is what you get. Sorry? Well, I don't need the 1 in front of that. I don't need that 1 right there. And so 1 plus tangent, that's what I'm going to say, right? 1 times something is just that something. 1 times tangent theta is just tangent theta. Okay? Sine 180 plus, you got to just notice it's a sine plus. That's your thing. Is sine plus. So find that one. Sine, cosine plus cosine sine. That's the pattern. That's the pattern. So I'm going to say sine, cosine plus cosine sine. 180. It's a quadrantal. Quadrantal angles, I'm not using the chart. I'm using the circle. So much easier to use the circle. 180 is over here. I'm talking about this point, negative 1, 0. I know sine 180 is what? 0. And I know cosine 180 is negative 1. All right, so don't trip over the algebra here. You know how to do this. 0 times something is 0, and negative 1 times something is just going to be negative something, right? 0 plus that something is just going to be negative sine theta. I'd skip all that green if... Example 6. This one's another important question. We saw one like it the other day, and I said this is going to be a test question. This is the same kind of deal. Suppose that A and B are angles in standard position with sine A equals 4/5, and we've got this stipulation, pi over 2 is less than A is less than pi, and cosine B is negative 5/13, pi is less than B is less than 3 pi over 2. Part A says find sine A plus B. All right. I don't think you even need to maybe read the direction part to see the pattern of this. This is a sine plus. And so you should be trained to look at your formula sheet or whatever and find the sine plus pattern. All right, so find that sine plus pattern. You see it? We know that a sine plus pattern is going to be sine, cosine, plus cosine, sine. And I don't think that's tough at all. I always like to take a second and just double check sine, cosine, plus cosine, sine. All right, so what we've got to do is fill in these 4 blanks. And we have some of them. Notice they gave me sine A. Sine A is 4/5. We can fill in that blank. And notice they gave me cosine B was negative 5/13. Okay, and that's all I have. So I always see this on the test. I'm telling you it's on the test. I always see this on the test. Don't do this. Okay? People will do wild stuff like this. Okay? Do not do this. They'll say, all right, well, A equals 4/5, so I'm going to say cosine 4/5 right here. That doesn't make any sense at all. Please do not do that. All right? Don't be the one that does that. Some of you are going to be the ones that do that on the test. I'm telling you right now. Don't be that guy. All right? That doesn't make any sense at all because I don't have A equal 4/5. I don't have that. That's not what I have. So please, please, please don't do that. We don't have that information. We're going to have to figure out that information either by drawing a picture or using the identities. For me, I would rather draw a picture. I think it's quicker if you draw a picture. So that's what I'm going to do. Okay, that's what I'm going to do. We are talking about an angle. Capital A is an angle. And what we've got right here, everybody overlooks this, or inexperienced students overlook that. But if you think about it, it's an angle. And think about where pi over 2 is and where pi is. What that statement literally says is my angle is in between pi over 2 and pi. They're describing a quadrant. Good. They're describing quadrant 2 without just coming right out and saying it. So what we have is an angle in quadrant 2. I'm going to draw a picture of this angle in quadrant 2. Angle A puts us in quadrant 2. And that angle defines a point, it defines a circle, but more importantly for us right now, it defines a right triangle. And it's the sine ratio that we're given. So we know the sine ratio is y over r. They're giving me the y and the r components of that triangle. We just need to find that missing component. And so it's at some point you're going to remember and you're going to memorize this pattern and you're going to know this number. For instance, I know this number is going to be -3. Okay, I know there's such a thing as a 3, 4, 5 right triangle that comes up all the time. I know it's negative because we're talking about an x number in the second quadrant. Now, if you didn't know that, that's fine. You can just say, well, x squared plus y squared equals r squared and do the Pythagorean theorem. X squared plus 16 equals 25. Subtract over, you got x squared equals 9. Square root, you're going to have plus or minus 3. And we just have to use the minus, the negative, because it's in the second quadrant. I know that's negative, okay? So what's the significance? Well, the significance is we're trying to find cosine of that angle A. And so we look at this picture, and we know cosine of that angle A. We know that ratio is x over r. So we've got the x side and the r side, -3/5. Cosine of angle A is -3/5. Now, I wrote a lot more right there than I would when I do this problem. I'm not going to write all that stuff. I know there's a 3, 4, 5. As soon as I write down the 3, I know my cosine ratio is going to be -3/5. So don't write all that if you don't need to. But now I need to fill in that fourth blank. And that fourth blank is describing, it's talking about a completely different angle. So I need a completely different picture. I've got angle B, and angle B is in between pi and 3 pi over 2. So picture where pi is and 3 pi over 2. Here's pi, here's 3 pi over 2. What quadrant are they talking about? Good, that's quadrant 3. You need to recognize that. So if I'm going to draw this picture, I'm going to draw a picture in the third quadrant. So I've got some angle putting me into the third quadrant. That's angle B. Angle B, that defines this right triangle for us. And we're given the cosine ratio, and we know the cosine ratio is x over r. So they've given us the x and the r components of that triangle. Now keep in mind, your r is a radius of a circle, and that r number will never be negative. So that's how I knew the x part was the negative part. The x number is the negative number because it's in that quadrant over there, the third quadrant, x is negative. That r number will always be positive. So I need to figure out that y side, and at some point you're going to know this number. You're going to memorize it because it comes up often enough. right now, you probably don't know it. So you'd say like y squared plus negative 5 squared equals 13 squared. Y squared plus 25 equals 169. Subtract over, y squared equals 144, square root, you're going to get plus or minus 12. Of course, since we are in the third quadrant, we know y numbers must be negative, so we're going to use a negative 12 there. That y number is negative 12, and why that's significant is because I'm trying to find the sine ratio of that angle. And we know the sine ratio is y over r, so use the y number and the r number, negative 12/13. Now, that's the trig part. The rest of this is just, can you clean up fractions? So we know how to multiply. You multiply numerators, you multiply denominators. Over here, same thing. You multiply numerators, you multiply denominators. Now, when we add fractions, we have a common denominator, so just add the numerators, negative 20 plus 36, you get 16/65. That's a pretty important problem right there. Questions on that? Now, if you didn't want to draw that picture, you could have used your Pythagorean identities. Sine squared plus cosine squared equals 1. That'll get you there. You're gonna end up, have to think about what quadrant you're in so that you know if it's negative or not. But that'll get you there too. I just like the picture because I'm going to end up using that picture again in part B. Part B, we see a tangent ratio, tangent plus. And so you don't have to have this memorized, just look it up. Find the tangent plus ratio. And the tangent plus ratio looks like tangent A plus tangent B over 1 minus tangent A times tangent B. I would highly recommend you write small on these tangent ones especially. Sometimes the tangent ones get kind of messy. A lot of fractions and stuff going on. All right, so that's your tangent ratio, tangent plus tangent over 1 minus tangent. So go back and think about your two pictures here. Your first one, when we did angle A, it was a 4 and a negative 3 and a 5, okay? What we need to get out of that picture is the tangent ratio. And we know the tangent ratio is y over x, so we look at y over x, we're going to have negative 4/3. So wherever you see tangent A is going to be negative 4/3. Negative 4/3 plus something all over 1 minus negative 4/3 times something, okay? Well, let's do the same thing for angle B. Angle B, remember, was in the third quadrant. And that was a negative 12, and that was a negative 5, I believe, and that was a 13. And so kind of same thing, we needed to find the tangent of angle B. This was angle B, right? Tangent is y over x. So that's negative 12 over negative 5. That's going to be 12/5. Negative over negative is positive. That's 12/5. So this is going to be 12/5. And this is going to be 12/5. We fill in like that. So far, so good, but now we've got to deal with all these fractions and stuff. Okay, and all these fractions, it takes a while. It's kind of tough, I suppose. Just take your time. All right. On the top, I see adding fractions. I need a common denominator, so I'm going to multiply by 1. Over here, I'm going to multiply by 1 to get a common denominator. Negative 4/3 times 5/5, that's negative 20/15 plus 12/5 times 3/3, that's 36/15. Okay. And all that's going to be over 1. Notice it's minus minus, so that's going to be a plus there. Bless you. I can multiply these, and that's 48/15. Okay. So I'm adding fractions on the top. I've got a common denominator. Okay, great. I've already got a common denominator, so just clean that up. That's negative 20 plus 36 is 16/15. But then on the bottom, I'm adding fractions. I'm going to need a common denominator. So let's call this 1. Let's change that to another version of 1, 15/15. And now we've got a common denominator we can add. Numerators give you 63/15. I think we've divided fractions enough to see what's going to happen with those 15s. Do we know what's going to happen with those 15s? Those 15s are going to cancel, right? And we're going to get 16/63. Now, the reason why, if you didn't understand that, remember when we divide fractions, we multiply by the reciprocal. Yeah, of course, they're going to cancel out. You're going to get 16/63. Divide fractions, multiply by the reciprocal, but we can skip that step. We know those 15s are going to cancel out. Tangent A plus B is 16/63. Now, part C is kind of tricky for some people, but it's the easiest one to implement once you know what to do. Find the quadrant of A plus B. All right, they told us that angle A, remember angle A was in the second quadrant. So, I guess it could be something like 100 degrees, perhaps. We don't know that. I'm just, I'm kind of throwing that out there. And angle B was in the third quadrant, and, that could be something like 200 degrees, I suppose. And so if you think about it that way, the quadrant of A plus B, we're adding those two angles together. So A plus B, 100 plus 200 would be 300. What quadrant is that in? That's in the fourth quadrant, correct. Now, the problem with that is I just made up those numbers. Quadrant 2 could have just as easily been a number like 170, and quadrant 3 could have just as easily been a number like 260. And if you added those two angles together, 170 plus 260 is 430. What quadrant is that in? That's in quadrant 1. So I guess you can't really do this because we don't really know what those numbers are. And so it could be 4, it could be 1. We can't really make any assumptions. But here's what we can do. From part A, remember how we found sine of A plus B was 16/65? Okay. That positive result tells me that A plus B is either in quadrants what? Where is sine going to be a positive result? Right, it's either in quadrant 1 or 2. Okay, I know sine can only give me a positive result in quadrants 1 and 2. But then in part B, we just did part B, and we found tangent A plus B was 16/63. That's also a positive result. So where is tangent going to lead to a positive result? 1 and 3, very good. So we have to do both of those things. Sine has to be positive and tangent has to be positive. That can only happen in which quadrant? Must be quadrant 1. So who cares what the numbers are? 100 degrees, 260 degrees, whatever. Doesn't matter. We know we're in quadrant 1. X2, we're back to verifying. Remember when we verify, we're trying to show that the left-hand side equals the right-hand side. Okay. And this, you look at this problem and you have no idea how that's going to work exactly. So, look for a pattern. What you should hopefully see is a pattern. We're trying to find some kind of formula that we can use, and then maybe clean up some algebra. That's what's going to happen. Now, highly recommend you write small. Okay, if you're going to draw this line right here, that's fine, but scoot way over and write small because there's kind of a lot going on here. When I look at this piece right here, I see one of my patterns. I see a sine plus. I see the sine plus pattern. So you just need to recognize that that is the sine plus pattern and go find it. Now watch this. I'm going to scoot way over here because my sine plus pattern is kind of long, right? The sine plus pattern says sine cosine plus cosine sine. That's the sine sum. Okay. Now, I've also got this. So that one to me is it looks like the cosine plus pattern. So go find the cosine plus pattern. The cosine plus pattern is cosine minus sine sine. And we are adding those two things, so I'll put a plus sign right there. But I'm adding two of the patterns together. And it's still kind of difficult to see what's going to happen because that left side looks way more complicated than the right side. But what I can do is some chart questions. So you should be able to look at the chart and tell me what sine pi over 6 is. What's sine pi over 6? 1/2. So I'm looking at 1/2 cosine theta. And right here, you should be able to tell me cosine pi over 6. Square root of 3 over 2 sine theta plus cosine pi over 3, another chart question. It's 1/2 cosine theta minus sine pi over 3. So square root of 3 over 2 sine theta. Very good. Okay, still pretty messy, but at this point, the best of you are going to be able to see how to take it home. Okay, remember, you're supposed to be looking over at the other side. That's the picture on the box. We're trying to put a puzzle together, and look at the box. We see what we need it to look like. We start trying to make the puzzle pieces fit. Okay. One thing I noticed that's super nice that's going to happen is you've got square root of 3 over 2s minus square root of 3 over 2s. What's going to happen with those two terms right there? Those two terms are definitely going to cancel out. So we don't need to think about it as algebra to be able to recognize that that and that are going to knock each other out. Now, if you look at what's left, we've got this and we've got this. Or if you think about algebra, 1/2 c plus 1/2 c equals 1c, right? And that's exactly what we need to have happen. That's exactly what's going to happen. 1/2 cosine theta plus 1/2 cosine theta is exactly cosine theta. And that's exactly what I needed. Cutie.